Yeah, groups tells us that, but from the periodic table, how do I locate groups? Where groups and columns, right? Groups and columns. The group 1 will be the first column. Okay, and that will tell us how many electrons are in the outermost shell. Good. What are periods? Number of shells. How do I know which period an element belongs to? Can't use the number on the left side. It's basically the rows. Right? The rows are the period which tell us the number of shells. Next. Okay. What does the octet rule tell us? They want to be 8 where? In the valence shell, with the exception of first shell. How many is that? 2. Good. So filling up is nice and easy, right? So for this example, how many electrons does this element X have? 17. So how would the electrons be spaced out or located? 2 in the first shell, 8 in the next shell. So we've got so far 10, 7. Okay. So filling this one is nice and easy, right? We just need 1 more electron. What charge would this ion have when it gains that electron? Negative. Right? You don't have to say 1, but just keep in mind there are sometimes you can have multiple, sometimes not just 1. Right? But if it gains, it's going to have negative charge depending on how many you gain. Every okay so far? What will happen to an element with that configuration? It will lose the electron. Why? It drops the next one has that 8, right? Because this one, if we're going to try and fill it up, it's a lot. Right? And we just drop that, gives us that. What charge would this ion have? Positive. Why is it holding a positive charge? It just lost an electron though. It lost a negative charge. Hence what's left behind is a positive charge, right? If we want to work this out, we would have had 17 protons here. And after it gains, that one will have 18 electrons, still 17 protons. This will be a negative 1. Here, that drew potassium, so that was 19 protons. Okay, once it loses that, 18 electrons, right? Everybody okay so far? I'll wait a little bit back for this kind of review of what we talked about. Okay, so 18 electrons, but we have 19 protons, and there is a plus charge. Okay, so any questions? Okay, awesome. Let's now talk about molecules and bonds. So let's first introduce, kind of talk about this first. Next, we'll talk about how elements, generally, we do have exceptions to every rule, but generally we do not lose or gain molecules. Okay? So they either lose or gain electrons, they become ions. What are isotopes, by the way? How are they different? Different number of neutrons. Can an element have different number of protons? And it becomes a different element. It's a different element. Same, that element only has that number of protons. You don't expect to remember it, but you probably will remember it. But we can always figure it out from that period. So only carbon will have 6 protons. 7 protons, not carbon. So that's isotope. Neutrons will change. We'll never change protons. If we do, it's a different element. Right? Radioactive isotopes do lose protons sometimes, they become different. Stay the same. Some. Not all of it. But ions are losing or gaining electrons. Cations. Oh, the name. So, Again, a suggestion is think about the T in the word cation. Hopefully, also looks like a positive sign. Again, that might be an easy way to remember. So how has a cation formed? Yeah, when something lost an electron is when we have cations. What group elements in what groups would become cations? Look at your periodic table if you wish.
1, 2, and 3.
1, 2, and 3. Very good. Right? Because they will lose electrons because they have electrons 1, 2, or 3. Okay? So that's generally our cations are 1, 2, and 3 in groups 1, 2. That's why hydrogen is in a weird spot. Okay? How many electrons does hydrogen have? 1. What would we normally think it will do to become that optical state? Same 1. It doesn't do that. That's an exception. Okay? Others are so greedy they can actually take the electron away from hydrogen very easily. Okay? So hydrogen actually loses, it becomes H plus ions. You may have heard of H plus ions. In what concepts might you be heard of? Not Google. Has anyone heard of H plus ions? No? Acids have H plus ions. So this is why, even though we would anticipate that they would gain, it's just what's in the nucleus of a hydrogen atom? Just one proton. So this one proton has to try and grab this electron and grab another. It just doesn't have the power to do so. It actually will lose it.
What happens to group 4?
Do what?
What happens to group 4?
Group 4, good question. Okay, so we're going to talk about it differently. They will not lose or gain, they will share electrons. Okay, excellent. What about group 8? What will happen to them? Nothing, because they're stable, they're inert, they're chemically unreactive. This will stay. Excellent. So cations became cations because they lost an electron. They dropped a full shell. Right? This one dropped one, so it had 4 shells, now it does not. There are 3 shells. Okay. While the other one, negative charge ions, are called anions. Okay. They have gained electrons. They are generally in which groups? Do you think we can find anions? 5 to 7. Again, it's because they generally do not lose or gain more than. Okay? They'll be generally 5, 6, 7. 5, 6, 7 also do something else. Okay, so let's define the molecules. Molecules are basically 2 or more atoms that combine to form. 2 or more atoms that combine to form. We can go further. You never heard of compounds? That goes one step further. It's 2 or more atoms, but they have to be at least 2 or more different elements as well. Okay? So all compounds are molecules, not the other way around. For example, oxygen gas is O2, that's a molecule, but it's not a compound because the compound definition is a molecule made up of different. This one is okay. Does anybody recognize that one? Water, H2O is water. What about that? Yeah, more specifically, it's glucose. Okay. And HCl? That's our table salt. Excellent. Anybody recognize NH3? Ammonia. That's ammonia. Okay, so ionic bonds. Ions are charged. Bonds, this is formed by the attraction of oppositely charged ions. Okay, I didn't draw it, but this is chlorine. Okay, so chlorine wants to become Cl minus. Or what does sodium want to do? Na plus, right? It wants to lose an electron. So ionic bond is the attraction of oppositely charged ions. So NaCl are best bonds, A like B. So okay, because sodium wants to give away an electron, chlorine wants to receive it, so that becomes Cl minus. This becomes Na plus, and they'll also hang out together. What will happen when these two hang out together? Yeah, they balance their charges, they become neutral. So NaCl, we do not write a charge. As long as they're together, it's a neutral. They separate out and they okay. It's the ionic bond that pulls this together. That's an ionic bond. So oppositely charged ions attract each other. Please note, if it's neutral, that means these charges must balance itself. So, let's try out a couple of, let's not draw, but hopefully since we've talked about groups, we can figure out what charges they will be. So, if you could, if you can come up with the charge of the ions of these. You don't have to memorize them, you just have to be able to figure it out from the computer. Either if you have one that I handed out last week, great, you come up with there is a charge. Positive or negative, but how much positive and how much negative figure out what group it is in, will it gain, will it lose electrons, right? If it loses electrons, what kind of charge will it have? If it gains electrons, it will have a negative charge. Depending on how many loses and gains we lose. element, by the way, name? Calcium. What group does calcium belong to?
2.
2. So will it gain or lose electrons?
Lose.
How many does it lose?
2.
2. What charge will it have?
Positive.
Positive 2. Sorry, talk about fluorine. Just to keep in mind. Okay? Again, if you're confident, don't worry about it, but otherwise, always just bring the money, especially initially. And what charge does hydrogen ion have? Positive 1, we mentioned earlier, loses electrons. What about sodium? What charge? Positive 1. What group is the potassium in?
Positive 1.
It's in group 1, hence the charge. Positive 1. Why is it positive 1 again? Because we lost one in the outermost shell. We lost it. What do we think about oxygen oxide ion?
Negative 2.
-2. Why is it -2?
Because it gains 2 electrons.
Yeah, why does it gain 2?
Because it has
6 in the outermost. So how do we know that?
in group 6.
It's already in group 6. We can figure it out by putting the electrons out. But we have the groups. It's in group 6. So it's got 6 electrons in the outermost shell. It'll gain 2 electrons. Again, I've seen both ways, the number first and then put -2. What about nitrogen ion? Why is it -3?
Because it has 5 in there.
Why does it gain 3 electrons? 5, because it's in the 5th group, so there's 5 electrons in the outermost shell. That means it gain 3, it becomes stable. What about fluorine? Will gain 1, right? So the charge will be okay. So let's do bonds. Yeah, let's talk about it and then we'll talk about concentration. So we talk about NaCl, right? What would be for potassium and chloride ions? If they come together, would they form nicely stable molecules?
Yes.
Yes. Why?
This one's positive 1 and
Positive
one's
one, negative one, and cancels each other. So what do we think will happen to calcium and chlorine? We're going to need multiple chlorines. That's correct. Because we have the equal and opposite, right? So we have Ca plus 2. If we just have one Cl, only one of that positive charge will be So we're going to need 2 of these. Then we'll balance out. So next question is how do we write it out? Okay, this can be a little tricky, but just there is wait. So H2O, let's look at that. What's in H2O? What elements are there first of all? Hydrogen and oxygen. Next is what does this number tell us? It's called the subscript. It tells us, yeah, we have 2 of whatever is in front of it. Then do I have 0 oxygens? 1. Remember what I said? A lot of times in chemistry we just don't write the number. Okay, if there's nothing written, it means okay. So So here it tells us there are 2 hydrogens and 1 oxygen. How should we write this one? Is it gonna be one or the other? Bottom one. Why is the bottom one correct? Yeah, 2 Cl, so the 2 has to be after the Cl. You just don't write the number 1. It's 1 calcium. Okay? Pretty good with that? Can you combine 2 things? Next 2 is, what's the molecule formed from calcium and oxygen? And then with the K, that's not body, K. What is that? Molecule, right? Combination of these atoms, these elements, but make ions. What's the charge on calcium ion?
+2.
+2. What's the charge on our oxygen ion?
-2.
So, they cancel each other out? Yes, right? 2 pluses, 2 negatives that cancel each other out. How would this molecule look like? Will it look like
Zero.
so what does that tell us?
There's 1 of each.
1 of calcium, 1 of oxygen. Right? There's nothing written there that means it's 1 of each. We have a chance to do the last one. Okay. What will the combination of what's this element again? Potassium and oxygen give us? K2. Why is it, what does it mean K2O and why is it K2O? 2 potassium and 1 oxygen, why?
Potassium is negative, or is +1. Oxygen is -2.
Because here it's +1, this is -2, so we need another potassium to neutralize this. Okay, so equal and opposite charges. It doesn't have to mean that it has to be 1 and 1. Multiple of 1 and 1 or multiples of 4. Okay. But as a unit, it has to be neutral, so the charges should balance. Thank you for efforts. We don't take time to understand why. If you chemistry, then I talk about other items.
So just, is there any specific order that you write them in?
Good point, thank you. So we always write the cation first, the positively charged ion first. There are very few exceptions when we do it. Okay? Otherwise, we always write the cations first, the positively charged ions first, then the negatively charged ions. Okay, that's why we wrote this as K2O rather than OK2. Okay, but that's the positive charge ion.
And if there's multiple positively charged ions, is there any way to format that? Or
So that a little bit, there are very rare situations, yeah, we just generally go by where in the periodic table it is, and then we'll put the ones that come first. Sometimes which have very good chances too, so it's a reader.
like
We
glucose?
usually have, sorry,
Like glucose?
glucose is different, actually, it's not charged at all. We're gonna talk about the next one, that is covalent. Yeah, they're gonna share. So if I said I have two friends, they're cohabitating, what does that mean? Yeah, same space. So co talks about share. Okay? So covalent. What's this valent about? Valence cell, valence electrons. Exactly. Okay, so they're sharing outermost electrons. Okay, so H2, how does that come about? So here now we go back to what hydrogen would love to do, right? Hydrogen has one, it wants one more. Yeah. Okay, so if I draw that out, I'm not drawing the nucleus. Okay, this hydrogen has one. Another hydrogen comes in. As long as they hang out together, both have 2 electrons because they're sharing one each, a total of 2. Okay. Hydrogen needs how many total electrons to be stable? 2. Each hydrogen only has 1. Okay. How do we think oxygen gas comes out to be there? O2. Let me erase some of this, it's too much. Let's revise again. What does this O2 mean? 2 oxygen making this 1 unit, right? How does it come out to be there?
You have both oxygens, which are going to both share 2 electrons with each other, so they're both happy.
Yeah, because each oxygen has how many electrons in the outermost shell? 6. So it wants how many electrons? 2 more, right? To get to 8. So they're going to share 2 each. Okay. Again, I'm only drawing the outermost shell. There is an inner shell for oxygen. And I'm not drawing what's in the nucleus. That's the total 6 electrons in the outermost shell. The oxygen. So it has,
Is that how you get a double bond?
yeah, feed into it, yeah. Okay, so here, how we'll write it is 1 dash between the 2 hydrogens. That tells us 1 electron each is being shared. Of oxygen, we would write it O double dash. Try and work out how nitrogen gas comes out to be. Nitrogen gas, N2. Please don't shout out the language, try it out first. This kind of a drawing. And then symbols as well.
Bless you. Wait, was it hydrogen?
let's go the other way. How might we represent the molecule of nitrogen gas?
They share 6 electrons.
They do. How should we write it out and draw it out? Why do they share 6 total electrons, by the way?
Because they each want to
Each one,
get to gain 3. So
3 electrons each, so they will share 3 each, they'll share total of 6. How should we write this short now? Yeah. Each line tells us a pair of electrons of each. These share 3 to become stable. And so why do they need to share 3 again? Yeah, we got 5 electrons in the outermost shell, they need 3 more. Okay. Again, I'm only drawing the outermost shell, there is the inner shell, there's nucleus. Right? We have 5 total outer electrons, outer electrons, valence shell electrons. Same. Three electrons each, pair, 3 pairs. Look at it, what's water then? H2O. How's that? Now we're going to have more atoms, say 2 elements. And there's about CO2 as well. We'll talk about carbons. Let's see if we can picture it. We can draw water, draw CO2 gas. Okay, what does oxygen want to do? Have 8, how do they get to 8? Gain 2 electrons. What does hydrogen want to do? Gain 1. Right, so that's why there's 2 hydrogen. Okay, so what's going to be in the middle of that? Oxygen is going to be in the center. It has total of 6. Shares. Again, I'm not drawing the inner shells first, the outermost shell. Draw the 2 hydrogens over it. Is this hydrogen stable? Yep. Is this hydrogen stable? Is this oxygen unstable? Yep. As long as all these three remain together, all of them are stable. How might we draw that up? In the middle. Dash page. Let's skip. Maybe we can skip this and go straight to this drawing for CO2.
Right now,
Yeah, your question or you the answer?
maybe the answer.
Okay, go first.
L, 2 lines, C, 2 lines.
Let's see. What will this tell us? Yeah, so is this gonna be stable, oxygen? Why is this oxygen stable?
Because it needs to.
It needs two, so it's sharing two with the carbon. Let's look at this oxygen same, and with the carbon stable. Yeah, how many electrons does carbon have? 4 total electrons. It's gonna share two each. As long as they stay together, carbon has its 8 is stable. Draw it up. Okay, so here the next few slides are to show those what we went through in discussion. Okay, they don't stay put, they do move around, but they spend time between. As long as they're together, they're very stable. Methane gas, right? What does carbon want? 4 electrons, right? How many does hydrogen want? 4. So CH4 exists because each of those electrons will be shared with one hydrogen. So the red here would be the carbon atom. With the electrons, hydrogen will be the one with the green. And again, they're moving, but they're spending time together, they're sharing. So single covalent, 1 electron shared between. We write it with a single line between the each. Double covalent, 2 electrons shared each. Total of 4 electrons shared. Write it up with a double line. And triple covalent basically is 3 electrons each. That's our triple covalent. That's single covalent. And then this will be our double covalent. I'm gonna make it complex. Next one we're gonna talk about something called polar covalent and non-polar. First of all, I have a magnet. Okay? Have you ever seen a bar magnet? It has 2 sides, right? One side pointed to the earth. Top of the earth is called the North Pole, bottom is the South Pole, right? So there is some distinct sides to it. Same thing with our magnet too. There's a North Pole end and a South Pole end. So whenever you hear the word polarity in our chemicals too, that means there's a distinction. Okay? Because I've seen it's easily crossed between the 2 directions. So non-polar means electrons are being shared equally. Okay? For example, these 3 would be non-polar. And then we'll talk about what causes polar in a second, right? Here, it's like having twins who have worked out the same amount, they have the same amount of muscle, they're playing tug of war. Is either one going to win? No, technically not. Yeah, one can get tired maybe by the time an hour but these are both sharing equally. Neither one has a stronger pull on those electrons, so these would be non-polar. There's no distinct sides. Water, on the other hand, oxygen, on the other hand, is not a very good share. I mean, it's a good share, but not very good share. Okay? Remember what's in the nucleus of a hydrogen atom? One proton. Right? So what oxygen does, think if you're sharing books, it's like a little bit of a hog. Like, yeah, I'll share you book. I'll keep it more towards me. You can look over my shoulders. Okay? That's kind of what oxygen does. It's going to pull the electrons closer to oxygen. Okay? So electrons spend more time around oxygen, so they are called what's called partially negative. Okay? They're not charged. If they're charged, they've taken it away. Right? This means it's partially negative. So the way we draw oxygen is not linear, but more like this. Okay? Because oxygen does not share equally with us. It actually pulls electrons closer to itself, which makes this side, because electrons are what charge? Negative. We use this sign, the delta sign, green sign, just to show partial negative. It's not fully negative, right? Now these sides will be partially positive. So this is a polar molecule. Understand polar molecules and know water to be a polar molecule. Polar molecules are when they do not share. One has a stronger pull. Again, we can get more chemistry, but it's beyond ours. It's called electronegativity. Okay? That's hydrogen sharing. Even carbon dioxide. Carbon is a good mediator. Nobody can take it away. It also does not take it away. Okay? So generally, carbon will not form. Generally, does not form a polar. It's generally neutral, neutrally charged. Polar covalent is when, I know this animation is showing that it's taken away. It's still sharing, just pulls it closer. Okay. So we have distinct charges, partially positive. I could not put the delta in there. Okay. So the hydrogen end, because electrons spend less time around the hydrogen side, they're partially positive. Oops. Okay, don't get it big enough that the next page also. This side is more negative. So it's like this is showing only one electron on this side compared to the two protons. Right here, it's our 6 at most, but 7 electrons. Okay, more time spent around oxygen, so there are more negative oxygen side compared to the hydrogen side. And why is this important? Please come on. Okay, then we talk about the third. So distinct bonds. So far we talked about ionic bonds, covalent bonds. In that covalent bonds we've got different types of them. The third bond we're going to talk about is hydrogen bond. It's based on these two. Okay? So hydrogen bonds are the attraction between a partially negative side of one molecule with a partially positive side of another molecule. Whereas both the others, we talk about ionic and covalent bonds, they are forming one molecule. Okay? So if I have water, it's the attraction between a couple of water molecules. So let's draw water like that. So this is partially negative, this is partially positive, partially positive. If I have right here, another water molecule, the oxygen from this water molecule will face this hydrogen, cause it will be attracted by that hydrogen, because hydrogen is partially positive, this is partially negative. And this bond that forms between molecules, we draw it with a broken line. Are hydrogen bonds. The attraction between a partially positive side of one molecule to a partially negative side of another molecule. That's a hydrogen bond, and we write with broken lines like that. So this image tries to show kind of two things. This is water, the red is the oxygen, hydrogen is the blue. So the oxygen side is partially negative, hydrogen side partially positive. Here is another water molecule, so the oxygen will attract this hydrogen part of this water molecule. That's the hydrogen. Yes.
So for every one molecule that forms hydrogen bonds, it has to have an even number, right?
It actually has multiple, which is quite curious too.
Okay.
Because it's again multiple, it actually forms this very intricate, big, huge molecule. One attracts the other, another one attracts it, as well as it can attract multiple
But
different.
what I'm saying is from every molecule, if it's got one oxygen, then it has to attract two other molecules.
It
And
can,
then
so,
you can
yeah,
keep-
I feel what you're saying. You have to
and
finish
then you
it.
just keep building off of that, right? But it has
Yeah.
to have like, like
So within that molecule, it's perfectly. It's 1 to 2, but this oxygen can actually attract multiple. It's not just one more.
Oh, okay.
It can attract 2 as well.
okay.
Because again, it's partially negative. It doesn't have to be equated.
Gotcha.
That's very good. Because that partial negative is higher than one partial positive. If that's what you're thinking about, 2, yeah, a lot of times it's 2 water molecules, the hydrogen parts attracted by an oxygen.
Okay.
Yeah, that. Out of the ones we've talked about, this is the weakest of them. You can separate this out easily, but there are features of this that makes this impressive. Okay? So again, these are intermolecular. What does the word or the prefix inter mean? Between. While intra, it's within one. The other two that we talked about, ionic bonds, covalent bond, that's intramolecular bonds. These are intermolecular, between molecules. But what's the advantage, do we think? They form like a big molecule because of all these attractions. They just keep attracting, they just keep bigger and bigger. Okay? Which is what some features of water comes out of it because of this hydrogen. Like for example, surface tension. Okay? Surface tension is how much kind of surface tension, but what it really means is there is this force between the water molecules on the surface which kind of protects that as a nice barrier. Right? If I had marbles, we put something through, it'll just go through. Well, here it's almost like a solid kind of thing. So of course, if this weight is too high, it's like us, yeah, we won't be able to work. Okay? But insects can because they're light enough and they have multiple legs, 6 or 8 legs, and they spread their weight on those things while we spread them out. Okay? So they're able to not break that barrier. We'll talk about something called surfactant, especially in our lungs. It's very important to have surfactant. Okay? Because we don't want the surface tension in our lungs. The surface tension will collapse our alveoli. If you want to do an experiment, take water, put some flour on it, and see it will float on top. Take another cup or beaker, put some soap in it, okay, mix it up, detergent, mix it up with the flour and see what happens. Okay, it will not float. Breaks those hydrogen bonds, it will lose surface tension. That's what in our lungs we don't want surface tension. Because that surface tension, our alveoli will collapse, will come back, because we'll talk about this again. Okay. Questions? Let's take stretch break and